All right, so we want to evaluate the functions. My first function is f of x is equal to 3x plus 7. My first question for you, even though this is not part of the lesson, this was part of the last lessons that we done, what it would be the domain of this function? What would be the domain? Good, why? Because it's a what? Yeah, it's a normal one. There's no red flags. Exactly. What are our red flags? Fraction with a variable in the denominator. A radical would be a red flag, or a variable in the denominator and a radical in the denominator. Aren't those our three red flags? If there's no red flags, what's our domain? All real numbers. All right, that's not what I was asking. I was just tying in the last lessons we learned. So I want you to find f of 2. So in order to find f of 2, we're going to go into our expression, 3x plus 7, and wherever I see an x, I'm now going to substitute in a 2. So now we are 3 times 2 plus 7. And then we just simplify. So f of 2 will be 3 times 2 is 6, plus another 7 is 13. So f of 2 is 13. Tell me what this means in our graph. Tell me what this means in our graph. Nico?
If x is 2, 13 would be y.
Exactly. In our graph, this is telling us if x is 2, our corresponding y coordinate would be 13. Okay, you guys do this one. Same function, but now I'm saying evaluate f of negative 3. All right, who has an answer for me? What's f of negative 3?
I got negative 2.
I got negative 2 too. Anybody want to see me do this? We're good? Okay. I'm going to step it up just a little bit. Let's say I now have f of 3a. Now, our function is f of x equals 3x plus 7. Now I want you to find f of 3a. So this means wherever I see an x, I'm not just plugging in an integer anymore. Now I'm plugging in a variable expression. So wherever I see x, I'm now substituting in a 3a, which is completely fine. So this is going to be 3, and now instead of the x, I'm going to substitute in that 3a plus 7. And then we simplify down. F of 3a is going to equal 3 times 3a is a 9a plus 7. So f of 3a is equal to 9a plus 7. Okay, I'm changing the function now. So now the function is going to be f of x is equal to x squared plus 3x plus 4. I want you all to find f of negative 3. right, who has an f of -3 for me? What'd you get? Janine? I got 4 also. Anybody want to see me do it? Good. Okay.
This other one, I want to see you do it because I got the wrong answer.
Sure. So I'm going to plug in -3 anytime I see x. So I'm at -3 squared plus 3 times -3 plus parentheses. Oh, there you go. Let's just keep going just for fun. The quantity of -3 squared is 9. 3 plus a -3 is a negative, not a -3, a -9 plus 4. The 9 and the -9 cancel, so then you're just left with a +4. All right, we're going to step it up a little bit. We're going to say f of a plus 1. We're still using the same function, but now this time wherever I see an x, I'm now substituting in a plus 1. So now I need the whole quantity of a plus 1 squared plus 3 times the quantity of a plus 1 plus 4. Okay, rookie algebra 2 mistake. What's the rookie algebra 2 mistake? You think you could distribute this in and this becomes a squared plus 1. Am I allowed to do that? No, you're going to erase it. All right, yeah, no, we're not allowed to do that. The only time you're allowed to distribute in the exponent if there's a monomial in the parentheses, meaning there's no plus or minus signs. Right? If this was just like 3a, then you could distribute in that parentheses. But the minute you put a plus or minus sign, you are not allowed to distribute in that exponent. So if we're not allowed to distribute in that exponent, what do we do with this? Anybody know? If we're not allowed to distribute in that exponent, what do I do with this? We're going to FOIL this out, or double distribute, whatever your teacher used to call it. So that means this is a plus 1 times another a plus 1. So now I call it double distribute. A times a is a squared, a times 1 is a. But now we're going to double distribute the 1. A times 1 is a times 1 is 1. And now when we multiply this all out, now we're going to combine our like terms. So we have a 1a plus another 1a. This ends up being a squared plus 2a plus 1. Now what should I do with that 3 and the quantity of a plus 1? What should I do here? What do we do with this one? Not Nico, somebody else tell me. What should we do with this one? I gotta learn names. If you don't participate, I'll never learn your names, and I'm so bad to begin with. Matt? We can distribute. Perfect. So we're going to distribute that 3. So now we're 3 times a is a 3a. 3 times 1 is a 3. So we're 3a plus 3, 3a plus 3. And then last but not least, we're just going to bring down that 4. So now I'm down here. I'm at this point right here. I've distributed everything I could distribute, but I'm still not done. Does anybody know why I'm still not done? What can I do? What's your name? Erin.
Like terms.
Good. We can combine our like terms. So we now know that f of a plus 1 will equal, the a squared has no like terms, but 2a and 3a are like terms. So that gives us a 5a. And 1 and 3 and 4 are all like terms. 1 plus 3 is 4, plus another 4 is 8. So f of a plus 1 is 8. All right, we're still sticking with the same function, but this time I want us to evaluate 3f of 5. This looks a little weird. Now remember, our function was f of x equals x squared plus 3x plus 4. When you have a number and then a variable, what operation does that represent? When you have a number and then a variable, like if I have a 3x, what does that represent?
Multiplication.
Really, that's 3 times x. So when I have 3 f of 5, this is 3 times f of 5. That's what this is saying to do, 3 times f of 5. So what am I going to do? I'm going to evaluate f of 5 first and take that and multiply that by 3. So we're going to do 3 times, and now I'm going to evaluate the f of 5. So we're going to say 5 squared plus 3 times 5 plus 4. Did I lose anybody with this? So I need to simplify what's inside my brackets first. So we know 5 squared is 25. Following PEMDAS here, order of operations. 3 times 5 is 15. And now we add 25 times 15 is 40, plus another 4 is 44. So lastly, we multiply, so 3 times f of 5 is going to be 3 times 44, which is 132. Okay, we're still using the same function. Now I want to evaluate the negation of f of 2x. Who thinks they have an idea of what I should do first in this, the negation of f of 2x, or the negative times f of 2x? What should I do first? Somebody besides Matt and Nico. Somebody new. Let me learn your name, please. What's your name?
Sophia.
Sophia.
F of 2x.
Good. In this scenario, we have to do f of 2x first. So I'm going to plug in that 2x anytime I see x. And we're still working with the same function. F of x equals x squared plus 3x plus 4. So we're going to have 2x squared plus 3 times 2x plus 4. In this scenario, can I distribute in the exponent? How many people say yes? In this scenario, I can distribute in the exponent. How many people say no? We absolutely can. Why are we allowed to where before I told you you're not allowed to? What's your name? Megan. Good. There's no plus or minus sign in that parenthesis. So I'm absolutely going to distribute in that exponent. 2 squared is 4. X to the second power is x squared. So we're at 4x squared. Then 3 times 2x is a 6x plus 4. But I'm not done here. Why? What did it tell us to do? It told us to evaluate f of 2x, but then it really said, isn't this negative mean multiply by -1? So I'm going to take this whole expression, and now I'm going to multiply it by -1, which essentially just means change all your signs or distribute in a -1. So negative f of 2x is going to be negative 4x squared minus 6x minus 4. All right, next one. Now I want us to evaluate f of negative 2x. Are these rules the same, the negation of f of 2x versus f of negative 2x? No, they're completely different. This is saying plug in 2x and then negate everything, multiply by -1. This is saying from the very beginning, plug in a -2x for x. So we're still working with the same function. F of x is equal to x squared plus 3x plus 4. We're going to now substitute in f of 2x, or sorry, -2x. So this is going to be -2x squared plus 3 times -2x plus 4. We can absolutely distribute in that exponent. What's -2 squared? Nico?
4.
Good. So f of 2x is going to be positive 4x squared. 3 times a -2x is a -6x. So I'm just going to write -6x plus 4. Notice how our answers are different. Our answers are different because we're not doing the same process. It was completely different processes. All right, I'm going to give you one to try on your own. Okay, we're still going to use the same function. Actually, no, I'll make the function easier. We'll say f of x is equal to 5x plus 3. I want you to find 2f of 4. Who has an answer for me? Heron.
46.
I got 46 also. Does anybody need to see me do it? They all got 46? Okay, great. All right, moving on to the next phase. This next part of the lesson, we are going to title it, actually, I want some graph paper here. Format. The graphs. Okay. We're going to do increasing, decreasing, constant. So what I'm going to do is I'm going to give you a graph. And from in that graph, we're going to identify the intervals that are increasing, intervals that are decreasing, and the constant interval. So our first one. Sorry.
Just on the bar.
It just wasn't coming out good. I had to erase that point. There we go. I'm just waiting for everybody to draw the graph. Okay, are we ready? All right, so now what we're going to do is we're going to identify the different parts of the graph. And the way we read a graph always is just like how we read in America. We read from left to right, so we read a graph from left to right. So you always start here, and then you go along this way, left to right. So let's pretend we're on a roller coaster left to right. If we're on a roller coaster left to right, when it's going down, when you're going down the roller coaster, you're decreasing. When you're horizontal, you're staying constant. When you're going up the hill of the roller coaster, you're increasing. So that's what we're doing here. So from left to right, from what interval to what interval are we decreasing? Are we going down the roller coaster? Well, and it's always on the x. We're always looking for the x. So this arrow, doesn't that mean it extends forever? So what does extend forever mean? What number do we associate with that, or symbol, should I say? Infinity. So we're going not from positive infinity, since this is the negative side, we're going down. So we're decreasing from negative infinity all the way to what number? -4, you got it. So we're going to say decreasing. And we're going to do this in interval notation. Do you guys remember which one's interval notation? Is it like the squiggly brackets, like x such that, or is it just like the parentheses square brackets? Which one's interval notation? Good, parentheses square brackets. That's the interval notation. So we are decreasing from negative infinity. We could never reach negative infinity. So that's why it's a rounded parenthesis. All the way down, we're decreasing all the way down to -4. Is -4 included? Yes, that's a closed circle. So we are at -4, square bracket. And then we're neither increasing nor decreasing here, this horizontal line. We're just sort of steady along, like it's sort of like pulling in for like the stop, right? For people to load back and load on and off the roller coaster. Janine?
I have a question.
Sure.
I like keep getting confused when we do like the interval notation, but like how do you tell like when it's gonna be like the round or like a bracket?
Okay, so anytime it's infinity, it's always round, because you can never touch infinity. It just keeps going on forever. Now, in terms of all the other numbers, you look, if it's part of the graph or a closed circle, it's square. But if it's not part of the answer, then it's a rounded bracket. So like, for example, I'm just going to give you, let's say I had an open circle here, and then it went on. So now in this scenario, it's at 1, but is that 1 included? No, so that would be a round bracket, a round parenthesis, and then infinity. Okay, so now let's keep going. We got our decreasing. Now we have our constant phase. From what number to what number are we constant? From what number to what number are we constant? -4 to 0. Are both of those numbers included for the constant? Yes. So now we say constant is square bracket -4 all the way to 0 on the x. Both are included. And then we are increasing. From what number to what number are we increasing? Erin?
0 to infinity.
Good. Square or round? What are we doing?
Square for 0, round for infinity.
Perfect. Okay. You guys try this one. Okay, so I want you to write all the different intervals. And there could be multiple increasing, decreasing constants when we're writing out intervals. You just go from left to right and identify them in the order they're showing up, left to right.
We're just doing the decreasing, constant, increasing thing.
Yeah, and you do, and like I said, there could be multiple increasing, there could be multiple decreasing, there could be multiple constants in a graph. You just identify them in the order they come from left to right in their interval notation. Okay, so I sort of color-coded. If we're reading left to right, do we agree left to right, this is increasing, constant, decreasing, and then increasing again? So we're increasing, constant, decreasing, increasing. So let's come up with the intervals for this. Nico.
I have a question.
Sure.
Why when the circle's not shaded in? Is that like intentional?
What happened?
When the circle's not shaded in, is that like intentional?
Yeah, that means it's not included. It's an open circle, so it's not included. All right, so let's talk about increasing. So here, I'm increasing from what number to what number? I'm increasing, this arrow means negative infinity, all the way up to, what is that? -1. That's a -1 right here. So we're increasing from negative infinity all the way to -1. -1 is included.
I thought it was only on the x-axis.
Oh, I'm so sorry. That is the x-axis. I looked wrong. I didn't mean to confuse you. Let's fix that. Sorry, -3. Thank you, Janine. Or is that Janine? No, you guys have similar voices. Maya. Thank you, Maya. Okay, then what's happening? Then we're constant. What are we constant from what to what? Charles? Good. -3 all the way to +1. Now we're decreasing. Yep, we're decreasing. What are we decreasing from what number to what number? In the back, what's your name? Kimberly. Oh, you're right. I'm all over the place here. Y'all are catching my mistakes. Good. That is a parenthesis because that's an open circle at 1. Then we're decreasing. We're decreasing from what number to what number? You got it. 1 all the way to 3. What are my brackets, parentheses here?
Parenthesis and then a bracket.
Good. Parenthesis on 1 and then a bracket on 3. Since 3 is included, 1 is not. And then last but not least, we are now increasing again. And we're increasing from what number to what number? What's your name? Daniela. Okay.
3 to infinity.
Good. What about parentheses, brackets? Somebody else tell me. Parentheses, brackets. Oop, I wrote 4. 3 to infinity. Parentheses, brackets here. What are we using? In the back, what's your name? Luke.
It's bracket on -3 and parentheses on infinity.
Good. Bracket on +3, parenthesis on infinity. Okay, one last thing for increasing, decreasing. Sometimes I'll ask you to create your own graph, and I'll give you the guidelines. So create a graph. Given -infinity to -1 is constant. -1 to 2, parenthesis on 2, bracket on -1, is increasing. Parenthesis on 2, square bracket on 5, is decreasing. And square bracket on 5 to infinity is constant. Do you think all our graphs will look the same? Do you think all our graphs will look the same? No, our graphs won't all look the same because it's not telling us anything about the y, right? So we could be above the y-axis, we could be below the y-axis, above the x-axis, below the x-axis, we could be somewhere in the middle. So it really doesn't matter. Our graphs could all look different, but the shape of the graph, the way it's moving, is going to look the same. So I'm opting to choose below the x-axis. It really doesn't matter. All right, so from -infinity to -1 is constant. So I'm going to go here and I'm going to go, and now 1's included, so I'm doing a closed circle right here. -1's included, so I'm doing a closed circle right there. Everybody okay with my first part, my constant part that I just did? Could I have done this above the x-axis anywhere I wanted? Absolutely. It really doesn't matter where you did it, above or below. All right, then from -1 is included all the way to +2 is increasing. So now I'm going to go -1 is closed, +2 is open, so I'm just going to go like that, increasing. Like again, I could have gone above the x-axis, I could have gone below the x-axis, it really doesn't matter. It's ultimately just the shape we're making. And I did an open circle on 2. Then from 2 to 5, we're decreasing. So now we're going down from 2 to 5. 2's not included, 5 is included, so I will go right here. Decreasing there. And then from 5 to infinity, we're constant. So just going right across. Like that. Oh, why did that happen? Okay, there we go. Okay, if you wanted to have made this like a more drastic decline, you could have. So you could have been like, I'm all the way here now, and then like that. It really doesn't matter because like I said, we're not being told anything about the y's. So it's just a general shape of what it's looking like. All right, very last thing we're talking about today are one-to-one functions. Right, in a normal function, which variable was not allowed to repeat? Was it the x that wasn't allowed to repeat or the y that wasn't allowed to repeat? X or y? Which one wasn't allowed to repeat? Anybody remember? Aaron?
Oh, Y.
X. Okay, the x wasn't allowed to repeat. So in order for it to be one-to-one, the x was not allowed to repeat. Because remember, we told you, like Sally, Ben, Lou, birthdays, like 9/23, 7/24, 8/5. Like Sally can be born on 9/23 and Ben can be born on 9/23. So the y, right, x comma y, all right, the y can repeat, but Sally can't be born on 9/23 and Sally can't also be born on 7/24. That can't repeat. So the x is not allowed to repeat, but the y is allowed to repeat for a normal function. And how did we test normal functions in graph? There was a test we were allowed to perform if I gave you a graph. Does anybody remember what that was?
Vertical line.
The vertical line test. So remember, if we had like a parabola, and we passed the vertical line test, we knew it was a function. So now there's a one-to-one function. What a one-to-one function is, the x can't repeat, but the y also cannot repeat. So let's write that down. X does not repeat. And y does not repeat. So for every y, there is exactly one x. So this is one-to-one. For graphs, it must pass vertical and horizontal line test. So I'm going to give you the function f of x equals x cubed. So I'm going to first test the vertical line test. Does it pass the vertical line test? Am I going too fast? Okay, I'll let you guys catch up.
See it draw the graph.
Okay, so does it pass the vertical line test here? Absolutely. So it is a function. But is it a one-to-one function? Not sure. Let's check the horizontal line test. So horizontal line test, you draw horizontal lines. And as long as the horizontal line is not touching the graph in more than one place, it passes the horizontal line test. So is this a 1-to-1? Yes. 1-to-1 passes vertical and horizontal line test. Yes.
Yeah, so with these, basically, guys, means I forget like what it means to pass or fail it. So it has to touch. You know what I mean? It has to touch the line.
So it has to touch only one time. So like look at my yellow lines, each yellow line. So like see how this yellow line only touches my graph here.
Oh, okay.
And this yellow line only touches my graph here.
Yeah, so if there was like a line above that and it hit both of them,
then it would fail it.
Okay.
And the same thing for horizontal. It has to touch your graph in only one spot. Yeah. So now I gave you one that does pass it. Now let's look at another one. All right, so this is the equation of y equals the absolute value of x. Okay, so first question, is it a function? Does it pass the vertical line test? I'll give you all a second to catch up. All right, how many people say yes, it passes the vertical line test? Good, it absolutely passes the vertical line test. So that means it's a function. What's my next question? Is it a 1-to-1 function? How am I going to now know if it's a 1-to-1 function? It has to pass the horizontal line test. And immediately, what do we realize? It fails. Why does it fail? Because the horizontal line is hitting the graph in two locations. So is this a 1-to-1 function? No, not 1-to-1 function. All right, we're done.